Good morning. Welcome to Krishna's classroom. It's after quite some time that we are meeting again. I was preoccupied with some travel and then some indisposition and so on. So, for the past 1 month, nearly for the past 1 month, we did not record any talk. Now we continue from where we left last time. We talked about, in general, about convex functions, and now we try to develop the so-called Jensen's inequality. So this is something that we are after. Before we state the theorem and then develop Jensen's inequality or state what Jensen's inequality is, let me make a remark that it is eventually a generalization of the geometric mean, arithmetic mean inequality. What is the geometric mean and arithmetic mean inequality? Let us see this. So let y1, y2 be positive. Then we have the following inequality, namely then half is less than or equal to so this is the AM-GM inequality for two elements y1 and y2. This is the geometric mean. This is the geometric mean of y1 and y2, and on the right hand side you have the arithmetic mean. So this inequality is known as inequality. This is the GM-AM inequality because on the left hand side you have the geometric mean of y1 and y2, and on the right hand side you have the arithmetic. So this inequality is valid. Now this is the well-known GM-AM inequality, and it's quite easy to prove. It comes from this. Whole square is y2, and which is certainly greater than or equal to 0. Comes from this, and now from this it is easily seen. This implies is less than or equal to half of y1 plus y2. Now, what is a possible generalization of this? Shall do it for n numbers. That is yi. Then and the geometric mean of is that is the nth root of the product of y1, y2, etc. yn, and this is the product of y1, y2, yn, the nth root of the product of y1, y2, yn, and this is less than or equal to 1 by n y1 plus yn, which is the arithmetic mean. This is the geometric mean, and this is the arithmetic. So that's a generalization of what we did. In fact, it's a very well-known inequality, and a classical proof of this can be seen in some literature. And that's a well-known inequality, and which is very useful in establishing certain other results. Okay. Now, what we are trying to do is to recast, if possible, this in a new language, or we seek a possible generalization of this GM-AM inequality in the context of the measure and integration theory, or rework the entire thing by introducing an appropriate measurable space, appropriate set omega, and a measure on that, a class of measurable sets, or a sigma algebra M, and a measure. So what is that we are trying to find out? We'll do the following. We'll take up omega to be the set yn, and then of course M the set of all subsets. Okay, and that is the set of all subsets of M, and on that we introduce the following measure. The measure is with the property that namely one by n, so that we have mu of omega is equal to Okay. Now let us rework the either side of this inequality. So AM is 1 by n y1 plus now this can be rewritten in terms of as an integral in the context of the measurable set, the set omega and the measure that we have introduced on that. Let us see how this is done. That's our first task. Okay. Consider the function y. That is the definition of g. It's a real valued function which is the identity map in fact on omega. Now what about the and of course we have the following: mu yi is equal to so that mu of omega is equal to 1. Sorry, this is 1 by n. 1. Therefore, how do you write this sum? Yn we can write as in the following way. Integral over omega. Omega is equal to the set y1, y2, etc. yn g d mu. This you can actually see is equal to 1 by n is actually g at yi mu yi. And this is equal to 1 by n. Gyi is by definition yi. Therefore, the right hand side as integral over omega GD. Now we have to do the same thing for the left hand side. Okay, let us see how we work on it. So here you need some ingenuity. In fact, I have worked backwards from the Jensen's inequality, but it's better to understand how we really arrive at it. Okay. Now we make an observation. Okay, what do I do? I rewrite G in a new form. Note that exponential of log G. Okay, or it is the composition of two functions, log and exponential. Okay, so this we shall make use of. So this is, once you realize this, then it is quite easy to rework on the right hand side. Sorry, the left hand side. Sorry, did I? Yeah, the left hand side. N, which is the geometric mean of the numbers now what one does is this. We rewrite this as, okay, let us take the log of this. This is equal to now this exercise we did to get this in the form of an addition, so that of a sum, so that you can recast in the form of a integral. Okay, now how do we rewrite this? Now this can be seen to be, when as we did here, this can be written as omega log G d. Why? Because G mu I is mu I. So this is the identity function. So log G will be log y1, log y2, log yn, which is in turn, let me just write this as 1 by n sigma log g yi into mu of yi. What is that? This is equal to, this is 1 by n, log gyi is yi, therefore this is log y1 plus yn. Okay. So we now use this, we use the following. One by n is essentially one by n, because exponential of log is itself. We use that. Now we rewrite this whole thing in terms of what is log y1, y2, etc. yn. This is actually log g. So you have this, I can rewrite as integral and this part I can write as, see, I have got this here, integral over omega log g okay, right. Now what we have is the following. See, we have the inequality given by, and we will write it in the form of the integral. Yeah. The gm, therefore gm of is equal to integral over omega to exponential of integral over omega log g. Now am of gd. Therefore, this is equal to thus we have exponential of integral over omega GD is less than or equal to integral over omega. Now we bring in both exponential and log inside. Now what we do is we rewrite this as integral over omega exponential of log GT. Okay, so we get this result. Now we write so this is the inequality. So the AMGM inequality is now rewritten using in the integration as an integral on an appropriate measure space. Okay. So that's the major step that we have done, which will give you some insight into what is to come. So now we do one more thing. So we write exponential x for every real number x. In fact, now log G write as okay. Therefore, we can express this in terms of these functions right here. Okay. Therefore, we rewrite this inequality phi of integral over omega Okay, this is the format of the Jensen's inequality. This is the format of the Jensen's inequality. Now observe that exponential function is a convex function. So the question that you ask is, is the fine. It is true for exponential function, so is it true for this one? So that essentially leads to the answer is yes. So this gives the Jensen's inequality. So let me state the Jensen's inequality and then possibly make some remarks and then end this talk. It's a very short talk. So I just wanted to expose this, and we will take up in our next lecture a proof of the Jensen's inequality. I just wanted to tell you why it is called the GM-AM inequality, or the generalization of GM-AM inequality. What justification is there for that? In fact, simply says that from the Jensen's inequality, one can derive the GM-AM inequality. Not only that, you can derive several inequalities. In fact, it's a whole class of inequality that you can develop by choosing functions f, mu, I mean the measure space, then the functions, the convex function phi, and the f appropriate. So it gives a very general expression of this inequality. So let me just make the statement of the theorem. Equality. measure space, and mu of omega equal to 1. It's a probability measure type of scenario. If f belongs to L1 mu, omega. Let that is f is bounded between A and B. So that phi composition F makes sense. Okay. Then we have phi of integral over omega f this is the Jensen series, and this is what we hope to do next time. And as an exercise, you can do the following. A generalization of AMGM inequality is alpha 1, alpha 2, positive numbers, such that y1 to the power alpha 1 alpha n is less than or equal to now rewrite this in terms of by introducing the appropriate phi and f. F which enables you to writing the inequality as a case of Jensen's inequality. Because you can immediately see that the choice of alpha 1, alpha 2, etc., alpha n are done in such a way that sigma alpha I equal to 1. In fact, in the GM AM inequality, these alpha i's are all taken equally, namely equal to 1 by n. Okay, so that's the only difference. Otherwise, it's the same as the GM AM equality. It's a generalization of that. In fact, this can be recast in terms of or Jensen's inequality by introducing the appropriate functions phi f and of course the measure space omega m. Okay, so thank you very much. That's a good talk. So next time we will prove the Jensen's inequality in the general scenario. Thank you very much.